We are live.
Okay, greetings everyone. Happy Holy Wednesday. It's that time of year when we prepare ourselves for Easter. It's a great feast day and time to go Easter egg hunting. My name is Mary Beth Iyer. I'm the North Region Representative for Life Scientific. And as your host, I want to thank you all for attending this segment of Life Scientific's Lunch and Learn webinar series. We do these broadcasts once a month, so please register on your website or subscribe to our LinkedIn or YouTube pages to make and save your seat for upcoming live stream events. The webinar live stream goes directly to your YouTube channel. It will be available for sharing and viewing on demand. Just share the link you used today, and you're able to watch as many reruns as you want. So if you want to ask questions, please address us in the chat box for the live version. Due to codec related issues, many older browsers no longer support the live stream functionality. So if that's your situation, just wait till the live's over and then go back, and then you can watch it on the same channel. So it just won't be the live version. So Life Scientific is based in St. Louis. It was founded in 1992 to represent manufacturers of parenteral production machinery. I'm based in Illinois. I cover a good portion of the Midwest. From aseptic environments through container integrity testing, packaging, our company has been involved in over 5,000 equipment projects throughout the Midwest. For more information, please refer to our website. And if there's any additional information or technical services we can provide, don't hesitate to get in touch. Our information's on there. Towards the end of 2017, we started representing LF of America through the Midwest. We just conducted several site visits around our territory and met with clients that are in their production field. We decided to go over the frequently asked questions from our meetings for the LF packaging line. LF of America is the U.S. subsidiary of the Lameplast group, which I'm sure a presenter will account for more comprehensively. Our presenter today is Diego, the General Manager and Business Development Director for LF of America. Diego first joined the Italian headquarters in 2009, working overseas for the first 9 months. Later, he moved to the U.S. subsidiary LF of America in 2010 as sales area manager to develop the market for the company's product and services from scratch. Diego is a graduate from the Bologna University in political science, majoring in communication and media studies, and acquired multiple post-degree recognition, which helped him better understand the industry he now is involved in. So with that introduction, I am going to turn it over to Diego.
Yes, hi everybody. Thank you, Maribeth, for the introduction. Thank you everybody for being here with us today. I'm trying in the meanwhile to start my screen share here. Hopefully this will start. Okay. I would like to thank you also the whole team at Life Scientific. We're very happy to partner with LSI on the territory. It's a great team of skilled and dedicated individuals, and thank you for providing this great opportunity today for gathering such an interesting audience. So my name is Diego Bulgarelli. I'm Business Development Director for LF of America. These are the topics that I would like to cover today with you on this Lunch and Learn webinar. I first will start with a brief introduction about the technology that we use, the injection molding technology for the manufacturing of plastic unidose vials. We will then discuss more specifically about a opportunity that this technology offers, and is the EVOH barrier in plastic unidose vials. We will then talk about a possible transition from glass ampoules as primary packaging to plastic vials for some products. We will then have a look at the PENTAFILL machine, the fill and seal machine that we manufacture to fill the vials that we mold, and also a quick overlook at a comparison between the injection molding technology and the blow-fill seal technology. I would like then to close the presentation with a presentation of the contract filling capabilities that we offer here from LF America, from Boca Raton, Florida. and also a quick overlook on other type of packaging beside the unit dose vials that we mold. Okay, so as a brief introduction for who is not familiar with our company, with our products and services, LF of America is the US subsidiary of Lameplast Group. We're in business since 1976 as a primary plastic packaging manufacturer for the pharmaceutical industry. We focus specifically on plastic unit dose delivery systems. These unit dose systems are used in ophthalmic, are used for a buffer solution for diagnostics, oral vaccine, spot-on product, skincare product, topical application, animal health, veterinary, nutritional supplement. Beside the molding of the packaging, we also offer contract filling service, both from LF of America for the US, from our Florida-based facility, and from COC, that is our CMO division in Italy, mainly for the European market. And lastly, we manufacture and sell fill and seal machine for our unit dose vials. As a group, we count on more than 300 employees, $60 million sales revenue in 2017. We mold our packaging in Class 7, Class 8 clean room. We are ISO 9001 certified for the molding of the packaging. More than 350 million units produced in 2017, of which we fill about 30% of those. We make our own mold in-house. We have more than 850 available mold. Currently working on 3 shifts, so 24/5, Monday to Friday, and close to 35 molding lines and 10 filling lines. Okay, so as I was saying, we focus specifically on unit dose packaging, unit dose delivery system. This is what we call the strip of 5 unit dose vials. It's coming in a ranging capacity from 0.3 milliliter, the tiniest one that you see on the top left, up to 10 milliliter, which is a third of an ounce. We mold using different plastic, and I will cover the different type of plastic in a while. What is the main advantage of going with a unit dose vial, of using a unit dose packaging? Well, first of all, the fact that you're using a pre-meter dose, so there's no risk of overdosage. And then you can also have a preservative-free solution by means that you are delivering the whole dose in the vials at once. We can also fill, we have the ability of filling with the strips with up to 5 different products, as you can see here with the 2 ml at the center of the 10 ml on the bottom. Not all the machines fill up to 5, but the largest capacity they do. Some example of product filled in our packaging. For the smallest one, the 0.3 ml, we see many sublingual dosage. Can be, for example, oral anti-allergy medication. We see many buffer solutions for diagnostic kits. For example, flu diagnostic, strep diagnostic. The 0.6 ml vials that you see next to it with the blue cap and the clear tube, the clear vial, is designed specifically for ophthalmic. This packaging is molded in 2 pieces, so it gives you a clean orifice and the ability to deliver calibrated drops at 0.05 milliliter. 1 ml and 2 ml are mostly used for a topical solution, veterinary drug. I invite you to visit the link that is on the top on our website to see all the different variety of capacity and combination of packaging that we offer. Sometimes our vials are associated with blow-fill-seal technology. We go to exhibition, visitors stop by our booth and they say, oh, you do blow-fill-seal. We do not do blow-fill-seal. We are not BFS. we use injection molding. Injection molding is a manufacturing process where the plastic is melt and then is injected into a metal mold where it fills an empty space. It then cools down and it takes the specific shape of the mold. So it's basically a two-step process. With the blow-fill seal, you have a packaging that is blown. Yeah, you actually have plastic, melt plastic that is extruded and then blown into the mold. And then during the same process, you basically fill and seal the vials. With an injection molding, you first mold the vial and then you transfer it to a second line that is the filling line, in this case, the PENTAFILL machine that we manufacture and offer as well. Benefits of this technology is injection molding definitely is more consistent in terms of quality of the injected plastic packaging. It has a smooth surface, much clearer and cleaner than the one that you can obtain with other molding technology. It gives you a clean orifice at the time of opening the vial. You don't have plastic tears or imperfection, and is very flexible at the time of customizing specific shapes or capacity or developing dedicated solutions starting from your requirement. Different types of plastics that we use for injection molding, mainly polyethylene and polypropylene. The polyethylene or PE is obviously one of the most common polymer used worldwide in the plastic industry. It offers, just to highlight some features, it offers a good barrier to water vapor, a good resistance to chemicals. However, is pretty weak to oxygen and is prone to gas permeation. Among the polyethylene, we use different grade of plastic, a low density polyethylene, which is the softest and more flexible plastics. High density polyethylene that is harder and it gives a better barrier. Or even linear low density polyethylene that gives a better resistance to chemicals due to basically his constitution. It's a more uniform distribution of the polymer chain. The polypropylene that we use, it's recommended for autoclave sterilization. So it can withstand 125 Celsius or 245 Fahrenheit. And it's usually recommended for the product that requires a terminal sterilization in autoclave or need to withstand for other reason at higher temperatures. The bottom line is that as a group, we work with our customers recommending the right plastic starting from the project requirements or from the product requirements that you present to us from the very beginning. One very interesting, as mentioned before, one very interesting opportunity that gives the injection molding is to work with EVOH. EVOH is a copolymer of ethylene and vinyl alcohol that basically gives a barrier to oxygen and gas. We saw that polyethylene is weak in terms of barrier with oxygen. So if you have a product that is that needs a oxygen barrier because it's sensitive to oxidation, then we have the capability of molding the EVOH in a multi-layer vials. As you can see from, in the image on the right here on the bottom, we can customize the layers of plastic. So the inner layer, which is in contact with the product, can be either a polyethylene or a polypropylene or a different type of material, starting from the specific requirements of the solution. Then we have a layer of adhesive, and then the actual layer of barrier with EVOH. And then we have another layer of adhesive, and the outer material, again, it can be customized and it can be different from the inner material. So you can, for example, have a vial that has a soft touch polyethylene in the outer layer and a polypropylene in the inner layer because it's a specific requirement for that product. We do a gamma irradiation of the vial after molding and prior to transferring those to the filling line. We usually irradiate at 25 kilorays, but of course this can be changed starting from specific requirements and a different protocol for sterilization. The packaging that is then gamma treated it's bagged into a triple polyethylene bags. We do a 100% fully automated leak testing on each single vial that comes out of the molding line. So there's a automated line that apply a pressure inside the vials and do a leak testing. We can mold in different colors. Possibilities are endless in terms of color matching. Of course, we look specifically for colorants that are in compliance with the USP. Color can be opaque or translucent. We have some colors available and others, again, that we can match easily to a color match test. Decoration options include PET printing, usually, of course, not recommended for pharmaceuticals specifically, but it can be a good option for cosmetics, skincare, or some type of veterinary diagnostic product. We can also label the vials, and we can emboss the vial, as well as we use inkjet coding to print the variable information on the vial, such as expiration date or the batch number. The majority of our strips of unidose vials can be closed, can be reclosed after opening, and can be reused multiple times. Usually, this is from the 0.6 ml capacity, so 0.6, 1 ml, 2 ml, 5, and 10 ml can be reclosed and can be used multiple times. Recently, we've been receiving, I would say, an interesting amount of inquiries and requests for plastic packaging as an alternative to glass vials. This is true especially for injectable products. We know that glass vials is widely used in the industry, and we also know the limitation and the risk associated to the use of glass vials. Glass can break during filling, so during the filling process, it's not easy to handle glass, or it's not as easy as it is to handle plastic. They can break during the use also, so they can expose the end user to a risk of being hurt. The solution can be contaminated with glass microparticles or even with metals that are part of the process in glass manufacturing. We have a couple of solutions. One that is currently available, and the other one that is in product development. And I would like to briefly introduce the two of them to you today. So the first one is a vial that is the one that you see in the picture with a lower fitting. It is currently available in 10 ml and 20 ml capacity. We mold these in polypropylene simply because the first product that went into this vial, it had to go through a autoclave sterilization. However, it can also be molded in polyethylene and in other materials. The way it works, basically, you first open the vial, tearing off the cap, which is the top part that you see in the picture, and then the female fitting on the vial screws into the thread in a sleeve on the male fitting on the syringe, as you can see on the bottom. So basically, the syringe screw onto the vial, and at this point, the content of the vial is transferred into the syringe. Then it is unscrewed, and the end user put the needle on the syringe. This is a good alternative to pre-filled syringes, for example. And again, this solution currently available in 10 ml and 20 ml and polypropylene material can be customized in different options. The second option, the second solution that we are currently working on is under development, is a basically plastic vial with a rubber stopper. The goal here is to obtain a vial that is identical to a glass ampoule with a rubber stopper on top. We are studying these options since a couple of months. We already confirmed the feasibility of these solutions, so we know that in terms of capability, we can do it. What we are doing now, we are basically evaluating all the possible requirements that the majority of injectable and other products on the market that use glass vials can have. For example, we know that part of the process of the glass vial is the pyrogenation, the removal of pyrogens from glass. We need to understand until what point this requirement is specific to the glass, or it's more generically related to a container for that specific solution. So here is a sort of a call for requirement. If you have this type of need, or if you're using a glass vial for your product, for your solution, for your customer product, and you think plastic can be a better alternative to glass, in this case, I invite you to work with us, to contact us and work with us to define any specific requirements that your product may have, as we are currently working on this phase right now. And we look forward to be on the market with a product before the end of this year. Okay, this pretty much covered the part that I wanted to go over regarding the vials, the unidose packaging. So the question is, once these strips, once these questions are molded, how do you fill them? Here is a snapshot to show the fill and seal process of our PENTAFILL machine. PENTAFILL machine is a very small, compact, linear machine. The process starts here on the right, station number 1. The loading can be automatic with a pick and place that takes the strips of 5 and place it one by one after another on the line. Or it can be manual, for the manual version of the machine, where the operator loads the vial into a carrier. The vial, the strips of 5 vials, is then transferred to the filling station. Filling station, depending on the capability of the machine, can have up to 5 nozzles. So we have machine with 1, 2, 3, 5, or 10 nozzles. Up to 5, actually, yes, we'll go over this later, but it can go up to 10 nozzles. Then the next station is the heat blow. So we blow hot air to soften the plastic in the seal area. The very important thing here is that the air that we blow, that the machine blows, does not come in contact with the solution. The air is blown horizontally from inside out and from outside of the vial, so there's no contact whatsoever between hot air and the solution, the product that is inside the vial. After we blow hot air, the strips goes through, it may be 1, it may be 2 heat sealing station, depending on the capacity and the size of the machine. And right after that, it goes to the cold crimping station that cools down the plastic and gives also a shape to the seal. As you can see, there is no trimming. So it's no trimming of plastic. It's a very clean process. The melt plastic, it's cooled down into the cold crimp. So there's no need to trim the plastic. There's no plastic fumes. The machine is suitable for filling in aseptic and be easily placed into an aseptic environment. It's all stainless steel. And at the end, the strips of file is unloaded from the machine with another pick and place, or simply pushed out of the machine onto a conveyor when it can be inkjet coded with the variable information. A few more information about the PENTAFILL machine. So as I was saying, it's a very compact, it's a small footprint. We have different versions, the A series that stands for automatic, and the manual series with the manual load of the vials onto the machine. In terms of capability, in terms of capacity, we go from 25 vials per minute for the smallest capacity up to 250 vials per minute. For filling system, we use either pneumatic pistons that are ideal for liquids, or time pressure tanks for any type of liquid viscosity. Can be from water-like viscosity up to gels, up to thick creams. We also have a control for an automatic product refill. The thing is, we use an 8-liter or a 12-liter tank for the filling, and these come equipped with an automatic product refill system, so that the solution is pumped from a larger container. It can be a 1,000-liter, 250-liter, into the 8-liter tank that is under pressure, that is pressurized. And from here is transferred through the nozzle, through the tubing to the nozzle that dispense the product, that dose the product. We offer after-sales service from the US. All the machines can come with a US certification for all the electrical component. And again, it's a very flexible, very versatile machine. The changeover between formats is fairly quick. It can go from half an hour, 1 hour, to a maximum of 4 hours for the more structured machine. The maintenance is very, very easy. The product contact parts are minimum. We have the hopper, we have the nozzles, and the tubings are silicone disposable tubes. Different models of machines. Starting from the right, you have the M5 or A5, depending if it is a manual or automatic. The main difference, again, is just the feeding system that is automatic in case of the A5. Goes from 25 vials per minute. And then we step into a double capacity, 50 vials per minute with an A10 or an A10. The A10 has 2 nozzles compared to the only 1 nozzle of the A5. Next machine in the center here in the picture is the A15. All the machine can come with an optional laminar flow that we can provide as well. The A15 has a capacity of 75 vials per minute. We then go to a fully electronic version of the machine. The A5, A10, and A15 still need some mechanical adjustment, while starting from the A25, all the regulations are done by the operator or the mechanic electronically through the PLC. So we have a 125 vials per minute capacity with A25, and double than that, 250 vials per minute with A50. Now, interesting things about these latest 2 machines is they are modular. You can start with an A25 and decide later to add a module and transform the A25 into an A50. We would basically integrate a second A25 and add a module that will allow to use the same control, the same PLC for both machines. I highly recommend to visit our YouTube channel, where you can see a video of all the machine in action and a snapshot of the different station. So you can see also the how the machine actually fill and seal. So as mentioned, injection molding is not blow-fill seal. With this slide, I would like to go over with you on a quick comparison. As we said, injection molding and fill and seal is a two-step process. So we first mold the vials. The vials cools down. It's a room temperature. It is then transferred to a filling line where they are filled and heat sealed with no contact with between the solution and any type of heat. If you have a product that is sensitive to high temperature, in this case, injection molding and fill and seal, it's an ideal solution. Blow-fill seal may pose a risk for heat-sensitive products. Blow-fill and seal, it's a one-step process. You have a pattern of plastic that is extruded into a mold. From here, it is blown, the plastic, into the mold. It is filled and sealed at the same time. So the solution comes in contact with hot plastics. PENTAFILL machines are very flexible. They allow to work with small batches. You go from as little as 1,500 vials an hour up to 10 times that, 15,000 vials an hour. And especially you can stop production anytime. You can do a simple 1 hour run or a pilot filling, which is this type of flexibility is not always granted by a BFS machine. Consider that the entry-level BFS machine starts at 10,000 vials an hour. And once you start a BFS machine, you really don't want to stop it unless there's some serious problem. I mean, BFS machine is ideal to work on 3 shifts. That's also changed completely the production structure that you may have at your facility. PENTAFILL machines have a very small footprint. They easily fit in existing filling environment versus a larger footprint required by a BFS machine. Parts changeover are real quick, as we mentioned earlier. When you have to change the parts for a blow-fill seal on a blow-fill seal machine, you don't only change the fill part, but you change the whole mold. So it's fairly big, and it requires certainly more than one person to complete the operation. Coming to the cost part, cost of machine is 2, if not 3 times less than a BFS machine with the same capacity. If you consider the 825 or 820, and if you compare the productivity that you can have with a BFS machine, the cost of a PENTAFILL it's half than that, is not 30%. Then obviously you need to compare apple to apple. So with an injection molded part, you need to add the cost of the part to the whole process, to the whole structure. However, the bottom line is that if you look at an initial investment, the initial investment that you have to do with a BFS machine is much higher than with a PENTAFILL machine, for which you can buy only the quantity of strips of unit dose vials that you need for specific projects. Interesting aspect, also interesting difference is regarding the waste of plastic material. With injection molding is a clean process. There's basically no waste or very, very limited waste. The BFS process per se has a large quantity of plastic that is actually wasted because it's cut from the pattern and cannot be used. Lastly, the injection molding technology allows for options such as the multi-layer packaging with the EVOH barrier that we saw earlier, or even it allows to have calibrated drops for ophthalmic use. So you know exactly what is the quantity that you are delivering with each use. It's consistent. You are delivering the same amount of API in both eye, and it offers a in general, a better user experience. What does it mean? That without having plastic tears, imperfection, when you have a clean orifice, also the perception from a user standpoint is much better. Another thing that is not mentioned in the slide is that with injection molding, since you have a distribution of plastic into the vial that is more uniform compared to a blow-fill seal, just because it's part of the process itself, the shelf life of a solution filled into an injection molded part may be longer compared to a blow-fill seal, where you may experience a quicker migration of product over the plastic, through the plastic over time, once it's on the shelf. With this, I don't mean to say that injection is necessarily better than BFS. My goal here is to present the benefits that an injection molded packaging has or may have, starting from specific product requirements or project needs. Now, it's not, of course, injection molding is not a replacement or for blow-fill seal. However, injection molding and fill and seal technology with PENTAFILL offers certainly some opportunity, offers our customer the opportunity to cover certain areas that are not possible to cover with a standard blow-fill seal technology. That is mainly where our offers is. Okay. Unidose vials are not the only packaging that we mold. Injection molding is not the only technology that we use. We also use extrusion blow molding, injection blow molding. Here are some of the other packaging that we offer, but I invite you to check our catalog online, our PDF brochure, and also images and description of other packaging that we highlight in our website. The first one that you see on top is a bellow bottle. It's a accordion type of bottle with a short or a long cannula. It is available in 3 ml, 9 ml, and now also in 50 milliliter capacity. For what we see here in the United States, is mostly used for hemostatic powder or for wound care type of product. It's very efficient at the time of delivering a fine powder to the cannula. The link that you see here on the slide on the presentation are linked to a video that shows usage of the bottle. It's a short and effective couple of minutes video that you can check on our website. Second packaging here in the presentation is a dual chamber bottle, one of the few on the market. It has a 10 milliliter capacity bottle on the bottom, the one that you see colored in blue, and a 1.5 milliliter reservoir on the top. It has a dropper to dispense the solution. It is designed to keep two products separated till point of use. It works well with lyophilized product, where you have a liquid in the bottle and a powder on the top. We can make this packaging also for two liquids. The way it works is basically once you peel off the seal, you apply pressure, you push down the cap, apply pressure from top to bottom. Doing this, you perforate the membrane and you let the powder that is in the reservoir flowing down into the bottle. So the powder enters in contact with the liquid solution. The user makes the whole packaging and then it delivers the solution through the dropper. Last packaging on the bottom, many of you may recognize it at this point, is getting more popularity here in the US as well. We started filling these packaging 5 or 6 years ago in our contract filling facility in Italy. It's a multi-dose preservative-free bottle. The top group is an Aptar group, is not a Lameplast group. However, we showcase this because we are validated vendors from Aptar for the manufacturing of the 10 ml bottles that goes on the bottom. So we do mold the 10 ml bottle that can be officially paired with the ophthalmic squeeze dispenser from Aptar. These multi-dose preservative-free work through a mechanical system of sterile filtration. So it allows to use a ophthalmic solution that keeps its sterility during 30, 60, 90 days. The link here is not to our website, but is to the Aptar official product video that shows how the product works. If you are currently filling this packaging as a CMO, if you are a CMO and you are currently filling this packaging in the US, we would love to hear from you to see how we can work together. We are currently molding this bottle in Italy, and we sell this bottle in the US. We distribute this in the US. We have the plan of starting molding the bottle also here in the US, like we are currently doing with some of our strips of unit dose vials. Besides this, we can work with you on the development of new packaging solution, again, starting from your requirements. We can design, engineer, prototype, industrialize packaging. We make our own mold. We start from our customer's requirement and we propose a shape, a geometry, a delivery system, a plastic that correspond to our customers' requirement, product requirements or project requirements. You can see here, for example, a child-resistant cap in a 5 ml capacity vial or a dual chamber vial. Here you have two different chambers, 0.2 ml capacity each, that deliver two products through two separate orifices. So the product mix after being dispensed, in this case, into another container. To complete the presentation on the offering of LF America and Lameplast Group, we offer contract filling from our Florida-based facility. We are FDA registered for the batching and the filling of OTC drug. We are EPA registered for that product. We offer filling for all our unit dose vials capacity from 0.3 up to 10 milliliter. We have different machines for a different capability. The same machine that we manufacture and sell to the market are used here in Florida to offer contract filling. We have a line to fill also the bello bottles. We have lines to fill tubes, standard tubes. So we also offer contract filling of other packaging, not necessarily only what we mold. Very reasonable MOQ for filling. We're talking about 10,000 units. In case of strips is 10,000 strips of 5, so 50,000 vials. So we offer filling, if you look at the chart below, for cosmetics, vet product, diagnostic, ingestibles, non-sterile OTC drug. We work out of an isolated clean room. So as of today, we do not offer filling for prescription. We do not offer filling for products that require an aseptic environment, sterile product, or for medical devices. We are ISO 13485 certified at our filling site in Italy for Europe. So we can fill medical devices that are distributed under the CE mark, mainly European market. However, we cannot fill medical devices that are distributed in the US. For this, we can obviously supply a PENTAFILL machine to be installed at your facility or at your customer facility, and we can supply empty packaging for you to fill. Here's a beautiful picture of a end of filling, post-filling line of our facility in Italy. All the different type of equipment that are required to, after we fill the vials, out of the clean room in a Class C environment. Come visit us. We will be exhibiting at Interflex in April, in less than 1 month, in New York. We will be more than happy to extend you complimentary registration, free registration. We will be showcasing our A25 machine at the Interflex show. Come visit us at booth number 2364. Looking forward to meeting with you there. Thank you for your attention today.
That's great, Diego. Thank you so much. That was a great talk, and thank you for your comprehensive analysis on the different packaging solutions LF America is producing. We strongly recommend reaching out and register your attendance on the Interflex in New York. Once again, LF will be exhibiting in booth 2364 and will exhibit their PENTAFILL machine, and they'll have a ton of packaging containers to show. So stop by and see everything in real life, be able to touch them, feel them, ask any other questions. On April 18th, we'll broadcast another segment of our webinar series. We'll go over some air conveyance solutions, mainly applicable to the beverage, food, and dairy industries. Our presenter will be Stefano Lodi of Vetromechanica, our conveyance manufacturer. Once again, I'd like to remind you all that you can check out the playlist of our past webinars from Lunch and Learn series on our YouTube channel and set a reminder for any upcoming ones. Thanks again, Diego, for taking the time here today. For all of you who attended, I hope we helped you better understand your packaging types and the key differences between them. LF is an exceptional company, and it was my pleasure to hear this presentation on their packaging solutions. I hope you'll tune in for their next broadcast too. Thanks, everybody, and have a happy Easter.